All right, so as I read the problem again, it says two families are going to are going to the zoo together. The first family buys 7 tickets. I'm going to stop right there. I'm just going to jot down that I have two families. Whatever I write down, you should be writing down. Let's write this down. And family number 1, the first family buys 7 tickets. So then there's probably the second family, and they're probably going to do something too. And since we're solving linear equations, we're probably going to do something with the first family and the second family, and somehow there's going to be something that equals, because equation is the same word as equal, or the root is. So I'm going to probably have some sort of expressions that will be somehow equal to each other or something like that. So right now I'm just going to list the information that I know. So it says the first family buys 7 tickets. The second family buys 3 more than the first. Okay. So now we're going to say whatever the first family buys plus 3. Oh, no, wait. I got to reread that. Hold on. It says they bought 7 tickets. The first family buys 7 tickets, which is 3 more tickets than the second family bought. So let's think about that for a second. I heard somebody blurt out the answer. If the first family has 3 more than the second, how many tickets did the second family have? Well, see, that's the thing. Even Mr. Adams almost got caught up. Sometimes we'll say when you see the word more, it means add.
4.
Yeah. Now, how do I... So we know that they bought 4 tickets. We're actually kind of doing the problem wrong, but that's okay. Well, we were supposed to write an expression and solve it, but that's okay. We'll just write it down. How do we know that? Well, on the screen, what it's saying is... two families are going to the zoo. The first family buys 7 tickets, which is 3 more than the second family. How many tickets does the second family buy? So now, another way to do this problem would be do I know how many tickets the second family bought? No. So I could do it like this. I could say that the second family bought T tickets, right? Whenever we don't know something, we can assign a variable to it, right? So we'll say that they bought T tickets. So then the first family bought 7, which is 4 more than the second. So I could just say the second family, I don't know how many they bought, but the first family had, 3 more. Right? Then it says, how many tickets does the second family buy? Well, one way to solve this is we know that the first family had 7 tickets. So it's an interesting thing, and you guys, we talked about this before. A lot of times when we're trying to learn something new for the first time, we set it up in a way that we can find the answer without really doing the fancy algebra, right? But now I'm trying to teach you the fancy algebra. So it's always a good idea to start off with something simple that you don't need the algebra, so you could double check the work that you're doing on the algebra. So essentially my equation is the first family has 3 more tickets than the second family, but we know they have 7 tickets total. I need to solve for t. In other words, I want to make it look like t equals some stuff. I want to get the t all by itself. Or the fancy word was isolate the variable t. What's being done to t here? What is this 3 doing to t mathematically? Yeah, we're adding 3 to t. So to get the 3 away, we do the opposite. What's the opposite of adding? Subtract. So I'm going to subtract 3 because that's what I'm trying to get rid of. Whatever I do on one side of the equation, I have to do on the other. What's 3 minus 3? 0. What's 0 plus t? 0 plus t? T. Okay. What's 7 minus 3? 4. So now, what did we just do? We found that the second family had 4 tickets, right? We knew that. And we were given the information that the first family, 4 plus 3 equals 7. Okay? Any questions on that?